Alright guys, today we're going to be doing the DC drive lab. So this photo right here is a photo of the trainer that you're going to be working with. So which is right here. So we've taken all the connections on the board and we've brought them out. So the beauty of this is that you're a little bit protected by the plexiglass here. And then instead of having the smaller pots, we've got much larger pots that you can change with your hands. And then we've got the quick disconnect connections here rather than connecting to the actual terminals on the board. A lot of the terminals are different sizes, so we've standardized them all with the quick disconnect connections that we have in the lab. Okay, let's flip down to the second page here. The second page is going to show you specifics on the actual board. So you can see here that these are the pots that are on the actual drive. And you can see, just make out that there's a black dot here for all of your factory settings for each of those pots. So what we want to do is take a look here, and we can see that all along this line here there's a number of different potentiometers that were there and have been removed, right? So they've, all of these pots where you see these wires on the board there, they've all been brought out to the larger potentiometers that are on the front face of the board. Down here you can still see there is time current limiting, so the TCL, then we have current limiting and the IR compensation as well. So those are set because we don't really have to change those, we're just having the motor not connected to the load, right, and we're having it freewheeling, so there's no load whatsoever, so we're not going to do anything with current limiting or anything like that. Okay, the number of other connections here, there's your start, common, stop, and then your main connections for your potentiometer. And again, those have all been brought out from the board, and we're going to make those connections on the top here. But the first thing you want to do is take a look at the actual diagram for the drive, and then out in the field you're going to take a look at all of the connections, all of the jumpers, and you're going to slowly walk through all of your factory settings for the drive. As we scroll down here, here's all our different statuses. Right, so taking a look here, we want to see that, like in the run mode, the normally open contact is closed and the normally closed contact is open. Right, there's a number of different things to look through here. Right, so here for the run mode, common to start has to be closed, and in the stop mode, the common to stop has to be open. Right, so go through here and during the lab you'll actually refer back to these. These are all from the cut sheet from the drive. Okay, all the ratings or voltages that we expect to see, right, it's going to run off of 115 or 230, so it could also run off of 2.8. Frequency is 60 hertz. You can see here the armature voltage range is 0 to 90 volts. So you can look at your voltages there, and then while we're taking voltages during the lab, you'll refer back to this chart and make sure that everything is working out to factory settings and your expected voltages from the drive. Okay, for this one, always read the cautions there. So we have the plexiglass that's in place over our drive, but everything that's on here, there's all those chips that are on there, they're basically just, crystals. They're PN material. So when they blow, then there's shards of each of those components that are going to come off the board. So always wear your safety glasses when you're working with the drives, and be careful because there's disgusting voltages on the drives. Okay, so be careful because we're working with 120 today. And I also want you to keep in mind here that even when you think the drive is off, the shunt field is going to remain energized. Okay, looking at this one, the DC drive does not provide a built-in start-stop switch. You'll have to connect the start-stop and the speed pot on the external control box. So again, this is our drive that we're hooking up, and we're going to hook up the start, the stop, and we're going to hook up the potentiometer to these connections here. If this doesn't work for you, then refer to this diagram as well, right? There's our start, there's our stop, common between them, potentiometer, and we're also going to plug it in, and we're going to make the connections to A1 and A2. The control box is this blue box that you're going to grab from the lab, which corresponds to this bad boy right here. So there's a number of different components in there, potentiometers and switches and relays that have been brought out to our quick connections here, but we're going to have to ring them out to figure out how they've been set up. Okay, so the potentiometer is going to be this guy right here. And then the switch that we're going to use for the start, the common, and the stop, that's down here. So this switch right here is the one that we're going to be using for turning the drive on and off. Okay, make sure that the start is momentary and the stop is maintained. Okay, and later on we're going to make sure that the speed is increasing when we change the potentiometer in a clockwise rotation. So taking a look at this switch here, let's just take off these connections here. So we have this switch, and in one direction it is momentary, meaning that it's not being held, and in the other position it's maintained. Okay, so this is a 3-position switch. It's maintained in this position, off in this position, and then we have a momentary start in the other direction. So we're going to have to ring this out and figure out which terminals are our stop and which terminals are going to be working for our start. Okay, these connections here, don't go ahead and just wire it up as is, because it may not work. These boxes, we tried to make them standardized, but there's a few connections that are off, so it depends on which box that you're working with to determine whether this is actually the common and whether this is the start and whether this is the stop. We just randomly grabbed colors here. I would have used this for the stop, but on most of the boxes, this one's actually used for the start. Again, over here for the potentiometer, just double check these connections. I would have made them if I was creating them to put this as the resistance, the total resistance, and this as the variable resistance for the wiper. But be careful, because some of them, they have the total resistance here, and the wiper will come off another terminal. So we're going to have to test them out with the ohmmeter. Okay, anytime that you're in doubt, call us over and we'll check your wiring before we throw on the power. So first thing we're going to do is prior to plugging the drive in, and just check off each thing as you go and enter your measured voltages as required. Are there any charred or blackened components? And it says below, a smoke diode would be usually the first thing to look for. So what we're going to do, and then we're going to look at the fuses as well to see if anything's been blown. So let's first look. You're just going to do a visual look at the actual drive, and you're looking for any components that have been smoked, right? Looking at our SCRs here, right? SCRs on the other side. Everything seems to be pretty cool with this guy. So we can do a visual check first. This one is a drive that a previous student has smoked. So be careful when we're doing the scope connections, then we want to make sure that the commons or the alligator clips are tied together. Otherwise we end up shorting out the bridge rectifier. So I'm not sure if you can make it out, but there are you can just make out that right here, see if I can get my finger in here. So right here are 2 of the diodes. Still hard to make out with the lighting, but those 2 diodes are smoked. You can see all around the diodes on the actual board that they're blackened and charred around the outside of them. So somebody has smoked those because they have ended up making the wrong connections as they're doing the lab. And for the armature and for the shunt, they have 2 diodes that are being shared. It's kind of like 2 bridge rectifiers that are in parallel. So they share these 2 diodes, and so if you screw up the connections, then what's going to happen is most likely those 2 diodes are going to smoke. So if anything's going wrong with the drive, you're going to check your factory settings and you're going to do a visual look to see if anything is smoked, right? So obviously we've got to work on this guy and take those diodes off and replace them out. All right, so hopefully nothing's smoked on your boards, but you can see what a pain to replace any of those components, right? You've got to obviously take off the plexiglass, you've got to desolder those components, find the same components, resolder them back on in order to make the drive work. Next thing we're going to check is we're going to check the fuses to see if anything's been blown. And with this one, if you're reading through the cut sheet for this drive, you have to actually provide the armature fuse. It doesn't come in the box. So those two fuses are mounted, usually they are mounted on the actual board there, but we've taken them out and put the connections over to the side here. So your shunt fuse and your armature fuse are on the side. All you need to do is just take a slot screwdriver and then back this off, and then you can take out the fuse, and let's see if we can focus in here. Come on. So with this one, we want to make sure that the filament is still there and the fuse is good. Okay, you may have voltage to the drive, you checked everything out, but if that fuse has been blown for some reason, then obviously the drive isn't going to work. So armature fuse seems good. Throw that guy back in there. And the shunt fuse, again, you're going to take that guy out and you're going to just double check to see that the fuse is good. Now, as we're checking those fuses, do me a favor and have the drive unplugged. Anytime that we're going to be grabbing stuff and throwing ourselves into portions of the circuit there, we're just going to de-energize the drive just to make sure everybody's nice and safe. Okay. Anytime that you're questioning anything that you're doing, then just unplug the drive, right? Double check your connections and then call me over before taking any meter readings or checking any of the components. So the fuses, everything looks good, right? Do they appear to be blown? Not yes, donkey. So they're not blown, and the next thing we're going to do is we're going to ensure the right incoming voltage. Now, we're at the end of the course, right? Everybody's gone through, being safe throughout the course. The voltages that we've been looking at so far have been low. Now you're just going to check the 120 on the plug. Okay, so just be careful, take some time, right? And when you're placing the meter leads in there, then be careful on your connections, right? And make sure that you are on AC voltage. So prior to taking that voltage reading, then you're going to turn on your meter here, and we're just going to switch it over to AC volts. Okay, so prior to plugging it in, put your meter leads in. So don't do this while it's energized, do it while it's de-energized. Place your meter leads in, make sure that the meter is looking at AC voltage, and then we're going to plug this bad boy in. Right, then we're totally safe, and when we were grabbing the leads, then there was no voltage applied to the plug. So now we're looking at the two connections on our plug here to see that the voltage coming into this guy, and today the voltage is 120. Depending on when you're doing the lab, it could be 121 volts, could be 118 volts. It depends on what machinery is on this floor. The voltage changes throughout the day on this floor and on any floor. The voltage is never 120. It's always around 120. But today it looks pretty good, 120.26 volts. Okay, so just make a note of your voltage. And remember later on, when we're looking at other voltages coming out of the drive, there are components in there that will most likely charge up to a voltage that's higher than your source voltage. So be careful. Anytime you're working on a drive, the bus that is being used for the drive could have a voltage that is higher than the source. If there's any capacitors in there, remember that your capacitors are going to charge up to the peak voltage. What we just took was the RMS voltage. Okay. Next thing we're going to do is we're going to check the potentiometer that we have on that magical blue box. So first thing we're going to do is we're going to check the potentiometers and make sure that they're all set for factory settings. So for this guy, we can see here that our factory settings are anywhere where we have this black dot. So the time current limiting, and IR, those guys are, we saw still on the board, but we're going to check each of these guys, our max, min, acceleration, and deceleration in the jog pot, to make sure that they are in the factory settings. So what you're going to do is just adjust these guys until this dot right here corresponds to the dot that we see on the cut sheet for the drive. Okay, so we're putting everything back to factory settings. All of our jumpers, as you go through, we're not going to be changing the jumpers with this lab, but if you were doing this out in the field, you would make sure that all of your jumpers are set to factory settings as well. Right, you can see here that anywhere where we have these red tabs, those are our jumpers for different, there's a jumper for torque and speed, right? Other jumpers are there for various voltages going into the drive. So anywhere where you see those red tabs is where we have the jumpers on the drive. So you'd make sure that they were all back to your factory settings. So everything's set up the same as factory setting. And the next thing we're going to do is we're going to double check our potentiometer on the blue box. So we're going to measure the voltage between P1 and P3, right? See if everything's cool. But let's check out the pot first to see how the resistance changes on the pot. So I've got my 2-meter leads on either side of the potentiometer here. And so now we're going to look at the resistance. Let's move this over so we can get everything in the shot here. So now we're going to change our meter over to resistance. And we can see that between these two outside connections here, I'm seeing 5 kiloohms of resistance. So now let's see whether changing the pot, so adjusting the pot, let's see if it changes the voltage whatsoever. So I'm adjusting the pot clockwise and counterclockwise, and it looks like the resistance is exactly the same. So those are on my box, those are the two external connections for my potentiometer. Okay, so what we're going to do is we'll move one of the connections over to here. This will be the white on mine will now be the wiper. And now as I move the potentiometer in a clockwise direction, it looks like the resistance is going down, and going in a counterclockwise direction, then the resistance is going to increase from 0, or roughly 0 ohms, all the way up to my 5 kiloohms of resistance. Okay, so there's our 5K resistance. Okay, between the other two, so between this point and this point, then we'll see the opposite. Here I have, when I have the pot totally turned to the counterclockwise direction, then the resistance is very low. And as I turn that pot in a clockwise direction, then the resistance is going to increase from 0 all the way up to 5K. Excellent. Okay, so now I know that my two outside connections are for the total resistance, the 5K, and then between here and any of these outside connections, that'll be my variable resistance from 0 to 5K. Okay, in addition to that pot, what I'm also going to have to do is I'm going to have to wire up my stop-start station into these connections on the blue box. So I've got to figure out which connections here are corresponding to my start and which connections are corresponding to my stop. So all I'm going to do here is just go to continuity here. And you can see that right now between this inside connection and the outside, I'm having no continuity. And easy now. Let's change the positions of the switch and we'll see what happens. So this direction was my momentary. Nothing's happening there, right? I still have an open. And in the other direction, so I have continuity. So that's your maintained stop. So again, I would have used the red for the stop connection, but now I know that between here and my common and this point right here, that's going to correspond to this closing in the maintained position. Okay, beauty. So now I know I can connect up my stop between the common and this terminal right here. Okay, let's move this bad boy over here, and let's check for continuity. Not going to have anything in this direction because I know that corresponds to this guy, the black. This is the off position, so I'm not getting anything. But in the momentary position, I'm getting continuity. Beauty. Okay, so now I know that to turn the drive on, I'm going to connect up between here and here for my start. So this will be my stop connection, and this will be my start connection. Okay, so we're referring back to the diagram at the beginning of the lab to see how to connect up our stop, start, and common, and then later on how to connect up P1, P2, and P3. But you can see here that I have the common going to this connection right here, and then I have my stop going to this connection right here, my maintain stop, and then I've got my start going to this connection here based on the continuity readings that we just did. Beauty. So now I've got everything set up so that I can keep the drive off, or I can provide that pulse to turn the drive on. Okay, next thing we need to do is connect up our potentiometer now. So we've got on our diagram, we've got this done now. We've got the stop, the common, and the start connected up into our drive. Next thing we need to do is connect in our potentiometer. So this should be our maintained resistance, and then this guy is going to be the wiper that goes into the drive. So this will be our maintained resistance, and this will be our variable resistance going into the drive. So looking at these connections, I now have my connections going from P1, P2, P3 over to my potentiometer over here. And I've connected them up based on the ohmic readings that we looked at before. Okay, the last thing that we need to do is we've left the connections open for the armature so that we can take voltage readings, but we do have to connect up the armature conductors to the actual motor, and that's what you'll have to do in the field as well. You'll have to connect up your shunt and your armature connections. Shunt connections are already made for us, but the armature connection needs to be done here. So let's finish that off, and then we're ready to rock and roll. So you can see here that I've got my A1 and A2 from the drive going to the connections for the motor. So we've got the jumpers now in place from A1 and A2 over to the motor. All of this was done prior, so I just plugged it in, but everything I was just doing prior to this was with no power applied to the drive. Right? That way we can fool around with all our connections, right? And we don't have to worry about voltages being present. Be careful on these ones. Like right now, I would expect there to be a voltage present on the end of that terminal there. Okay, so we want to do all those connections with no power applied and then plug this bad boy in. Okay, we're messing with large voltages here on these terminals here. So be careful, be very careful on any of these connections on your F1, F2, A1, A2 connections for the drive. Okay, so still building up to the point where we can take those voltage readings. We're now looking at the LEDs on the front of the drive here, and we can see that we have power applied and that we have a signal going into the stop now. So that's happening because we have this switch in the maintain position, right? So remember we connected up our common, our stop and our start here. So we're in the maintain position, so that signal into the drive is telling it to keep the drive off. So now what I'm going to do is I'm going to switch this switch to the middle position, and then I'm going to provide that pulse to the drive, and at this point you can see that the drive has now turned on. So let's do that again. There's the off position for the switch, that's my maintain position, right? So now you can see that the drive is stopped. The one beside here in the red, this is for current limiting. So if the overloads have tripped, there's like a solid state overload circuit in this drive. So if the overload is tripped, then the red light is going to be turned on. So right now we're stopped, and then if we put it and provide that pulse of voltage to the start, then now you can see that the stop LED has turned off, and now it's just the green LED, and you can see that the motor, you can hear the motor just starting to churn, And so now I'm going to change the potentiometer, and by changing the potentiometer, which is this guy right here, right, so that is changing our set point or our speed control to the motor. And at this point, by going counterclockwise, I'm increasing the speed of the motor. So that's not what I wanted. So what I did was, because I want this so that when I go clockwise, it increases the speed of the motor. When I go counterclockwise, then it reduces the speed of the motor. So I know that this is my wiper going to the drive. So what I did was I changed these two outside terminals here. So I changed the reference voltage going to that potentiometer, and that way now when I increase it in the clockwise direction, so I'm fully clockwise now I'm going at full speed. If I go counterclockwise, then the voltage is going to be reduced. And as the voltage reduces to the pot, then the speed slows down on the drive.